I'm here with Balázs Máté, staff data engineer at Bitrise. Balázs, thanks for joining us.
Thanks for having me. Happy to talk
So
to you about the DPT.
it's we are good friends, and I also know that you are one of the major DBT users in the region. Can you can you tell us a little bit and tell the students a little bit about Bitrise, your use case, and your role in Bitrise?
Yes. Thanks. So Bitrise is a mobile DevOps platform for iOS and Android. What this means that we have mobile teams to build, test, monitor, and do all kinds of things with their mobile applications. And we gather a lot of data out of these systems that we need also for reporting, and also we needed to bring it back into the product itself, to charts or different numbers that the build machines can be optimized and things like that. I work in the data team as a staff data engineer. Previously, I worked in another company as a data engineer, and before that, I worked in mainly web development with C Sharp and the .NET framework. So it was more of a software engineering background, pivoting into data engineering that seems closer to my heart.
Oh, nice. And can you share a bit more about your data stack, like high level? How can we
Yes.
imagine? How does it look like?
So basically, uh, each part of the data platform is on GCP. We are mainly a GCP shop in general. So the crown jewel, to say it so, is BigQuery, the data warehouse solution in GCP. But we use Airflow, we use Dataflow, their managed Apache Beam system. We use Debezium for CDC from our operational databases that are, uh, I think, mostly or probably all of them are PostgreSQL. So we gather all the data with different scripts in Airflow or with Debezium or BigQuery data transfer. We land it in BigQuery basically as an ELT, extract, load, and then transform. And the transform part is with DBT. We build up a staging layer, then an intermediate layer, then a mart layer, and the reporting layer. Some call it bronze, silver, gold. In our parlance, it's this staging intermediate marts. We transform it in all kinds of ways, and then the mart and reporting layer is exposed to Metabase, our visualization tool. We used to have Tableau, but we migrated away from it. It's easier to use for most of the people, and it's much cheaper.
Mhm.
And then with reverse ETL, we push some of this transform data back into the source system, such as HubSpot, Salesforce, and also we push it to PubSub so other consumers in the company can use it. So basically, we put it in, we transform it, and then make it available or push it somewhere else. And basically, I described how my regular day looks like. And on top of that, of course, there are some problems every now and then that we need to fix. But when I try to explain to someone what data engineering is, it's basically pushing data from A to B
Mhm.
as
Mhm.
performant and as cost optimized as one can do it. So that's how it looks like. We have Marimo as our notebook environment that the data analysts in our team are experimenting with great delight. And also we have our newest addition, the AI Data Analyst, built with Claude into a Slack uh, bot, and also it's available as an MCP server for Cloud Code or Cloud Desktop usage. So basically, all the marts and reports that we expose in Metabase are available for this. We call it data mage, our data analyst, that can come up with different queries using the descriptions that we have in dbt, and it can create different charts in Metabase and look up our metrics catalog that we have also in dbt. So it basically just pushes everything to 11 from an automation standpoint or a self-service standpoint.
Sounds like quite a modern solution. And you said that your daily job is just like pushing data around. Can you shed some light about like the volume of this data, the whole complexity of your models and tests, especially in DBT?
Yes. So we have tens of terabytes of data, but I think the vast majority is confined to a handful of tables. So our main models or main tables are, I think, just a couple megabytes of storage size, but we have some very important ones that are like event-based that can get into the terabytes quite easily. So we have to be careful how we manage those tables because running an unoptimized query on it can be quite costly in BigQuery. So it's not a huge volume, but in this day and age, you can build a petabytes of data warehouses. But um, some of the most important models that we work with for pricing calculation and whatnot are, can be just megabytes. So it doesn't tell all the story. We have, I think, more than 1,200 models now.
Wow.
As I said, with staging, intermediate, marts, and reports coming from 10 or 30 plus sources, so different databases, different software as a service applications, different libraries that we need, like MaxMind for geographical data.
Yeah.
And we have 4,000 or so Metabase cards that basically are exposures to our tables. With testing, we have 1,000, 2,000, I think,
Wow.
tests. So it could be more, but it's mostly making sure that primary keys are really primary keys, so not null and unique on ID fields. And we use unit tests in some cases where we need to make sure that all corner cases are covered and we can make sure that there's no regression there because it's some business critical
Hmm.
transformation or something like that.
And what pushed you to DBT? Have you tried other technologies? Like how did you end up using DBT to such an extent?
Yes, before I think many teams, like most of the teams, I think, or even before, and now they had some kind of a homegrown solution. So in the previous company I worked for, we used Postgres, um, our data warehousing solution, and there were some Python scripts and some control tables that you could manage the references, and that Python script made sure that everything is run in order. But it was a mess to keep it up, and also after 60 or 70 models, it was really hard to keep in mind like which one references which one, and then we built some visualization tools to see like how the DAG looks like, but it was a mess and it was hard to maintain, and you couldn't really distinguish between production and test environment. In this company, there used to be a low code or no code solution that extract. I don't remember the name of that, but it wasn't that popular. But basically, you could extract all kinds of data, and then you could run SQL queries on top of it, and then you could drag and drop a graph of SQL transforms. But also, it was hard to maintain. You had no Git support, and And again, you couldn't really differentiate between the different environments.
So what were the features DBT gave you that were most useful in practice after using these tools?
Yeah, one of the things that, as I said, I came from a software engineering background, and now some of these things seem like table stakes. But 4 or 5 years ago, having everything in Git or your SQL queries, it wasn't that common. And basically, having that and running CI on it, and being able to write tests and having a different environment just for yourself as you would have in your local machine, that was a huge plus. And also the syntax, it didn't seem too cumbersome. It seemed like you can easily migrate your existing SQLs to this Jinja format. So it seems like it's an easy step without 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 making without feeling like that you are closed in. So you could just go back to your old one and you just give it a try, and it seems like it's gonna stick. Then you can move forward, and it's easy to use it incrementally. So feature by feature,
Mhm.
you just write a model, you just write a source, you write a few models on top of it with source references and refs, and then you can write tests, and then you can write documentation, and then you can somehow expose that documentation, and then you can write unit tests. We have some Python that script that you want to run. You can use the UDF function later on. So basically, you can grow with it. And the I don't think, and my colleagues I think would agree that the learning curve is too steep. So you can basically start bit by bit. And if you
Mhm.
are familiar with some kind of YAML, some Python and SQL, then you will be able to get by. So it doesn't feel like rocket science, but still it helps with a ton of things that most data engineers or analytics engineers would have to come up with their own solution. So it just made life easier, and it was nice that somebody already thought about it, and you can just use it. And DBT packages, we use a few. Those can come handy. Also, the community was a big plus. Back then in 2022, it was quite small, organized on Slack, and then they had these weekly office hours, and I just had a small script that I could showcase and get some impressions and some feedback. So it was pretty nice. Of course, it grew exponentially or tenfold, hundredfold since then, but I think they are still quite helpful. The documentation is well maintained and easy to use. So those are the pluses. And it
Nice.
wasn't hard to onboard other colleagues, but we can talk about it later.
Yeah, talking about, so you started with Git and talking about colleagues, there are, how many people are on your team who work with DBT and actually push to Git?
I think eight, and
Wow,
every now
okay.
and then some adventurous software engineers come in and then just create a new PR, and then they contribute. But I think like 7 or 8 people on a weekly basis.
I think like right now what you just said that they open a PR. What I see is that our students are quite good in picking up on all of the concepts, but when it comes to like real world production settings, there they would appreciate some input from industry players. So can you unpack this a little bit, like how your dev prod setting works in the CI/CD part of your system?
Yes, so it didn't just happen at once that we have this current setup. It took years of experimenting, some dead end streets, some improvements. So basically, you have Git, of course, and then we use VS Code, and we use dev containers so that all the requirements are set up and built. So basically, you just need to open the Git repo, in VS Code and you just set it up. You check out a new branch, and basically it pulls the production manifest from GCS and sets up your local profile where you can start in your own dev environment coding. So basically, let's say you want to modify one model and add a new one. And once you did this checkout and the automatic setup, then you start with the modification. You can use an alias that we use for dbt differ to only run the models that you modified or that were added. So basically, you don't have to build up 1,000 models, just the two or three that you need. And if the references are non-existent in the dev environment, then they will defer to the production environment. So you can use that data all along. You run it, you run your tests, you can compare it with the production numbers, and basically you commit it. We run some checks as a commit after a git commit hook to make sure that it's linted and everything is your referenced with a ref or a source instead of like just the plain BigQuery table identifier. And you commit it, you open a PR, then we create a separate CI environment for your branch where we usually just run a slim CI. So basically, again, just the models that you modified or added and all the dependencies. So only the things that changed. And we run the unit tests for these models. And if it works, if it passes and you get a peer review on your PR, you can merge it. We create a new container. We push the documentation to GitHub pages. We update some descriptions in Confluence and in Metabase. And on the next Airflow run, we just pick up with the new models and we run it as is. So basically, you have an environment per branch, so you know that your colleague is not going to step on your foot while in the middle of development. And also, once we merge the PR, we clean up these ephemeral data sets in BigQuery that go into a separate project with some
Mm.
prefixing, so you know that which branch it belongs to. So it's pretty automated now. And I wanted to mention that for CI, we run everything with the minus minus empty
Mm.
clause so that we don't have to do the heavy lifting in CI. Uh, we only do that for a few highly critical models, but basically it shortens the PR run, and also it doesn't cost anything because it's with empty. So basically, all the tables will only have 0 rows, but it will have the structure and the schema that you want to validate and make sure that the DBT run in production won't fail.
That sounds very, very major, and it's very much in line uh, to in like what DBT Labs suggests, but probably a more advanced version. So you talked a lot about why DBT rocks. Can you tell a little bit about what you're missing or what are the most challenging problems you encountered while using DBT?
Yeah, there were a few things. The incremental models back then they weren't as sophisticated. I think you couldn't use the merge, only partitioning in BigQuery, and you had to finesse it a bit. But for a couple of years now, it's easy to use, and you have two different options that can be quite powerful. So that one that was missing. Stored procedures are not first-class citizens still, as far as I know. You can
Mm,
use UDFs in DBT models now, but stored procedures are can be solved with custom materialization, and it made things a little bit tricky at first. It may come. Um, Otherwise, it's cost control, but I think it's true for cloud environments in general, that you always have to be mindful like how much it costs in, especially for BigQuery, as we are using on-demand pricing. So basically, you pay for every query, and you want to make sure that you don't blow it out of the water and then just try to minimize your costs. So incremental models are a must to make sure that you are not rebuilding everything all the time, and you only run full refresh when there was a major change that you need to make sure that is reflected
mhm,
all through the graph. So for cost control, it's getting better, and but you need to be vigilant about it and check it mm, on a weekly basis, let's say, or have some alert in Datadog or in
mhm.
your homegrown solution to make sure, or use quotas in BigQuery so that it's manageable. Otherwise, we are pretty happy, and there's not much that we are like aching for or waiting for. It seems like a mature product. And yeah, one thing, the metrics layer that everybody was talking about, and now it's a bit on the back burner, but may come back because of the AI agents could take advantage of it. I know it's available in the paid solution, but we are running it on our own infra, so it's more restricted. Something for the general public, I think would be welcome.
Mhm.
Something that's supported throughout all the major data warehousing solutions.
All right, thanks. I think like everything you said, it's very much golden information for our students. So just to wrap it up, if you could give just two or three advice to students who are maybe just getting started with DBT, what would be the most useful advices you can think of?
Yeah, give it a try. You can learn it step by step, and just build your first model, your first test, document your first model, just run it, and just commit it to Git, and then have your colleague modify it, and then you feel like you're a rock star. Uh, but be vigilant about costs. Use incremental models as much as you can. Try to model your data so that you can take advantage of it. And partitioning and clustering in BigQuery is pretty important. And I know it from experience that documenting and testing your models is usually not the main priority, but it can pay dividends later on for reporting, for new colleagues or new users. And this in this AI era, it can help a ton for AI agents. So basically, we made sure that all our marks and reports are well documented. And when we came up with this AI data analyst, it had pretty sophisticated column level information about the available data so that it can make better decisions and can come up with the best queries possible. So yeah, document it and test it, as everyone would say it in the software engineering world too, but it pays off now. It does feel like so. Yeah, do it.
Okay, note taken. So thanks so much, Balázs, for joining us and sharing your expertise.
Thanks. I really enjoyed it, and yeah, it helped me think through a few things like what we did well, what we did wrong, and how we evolved throughout the years.
All right. I'm happy for that.
Thanks.